An ideal gas enclosed in a cylinder fitted with frictionless, weightless piston. Just an example, an ideal gas is enclosed in a cylinder having weightless, frictionless piston. The piston is pushed outside, means upwards. When the piston is moved upwards, means work is done by the system. When work is done by the system, conventionally you have to give W negative sign. They asked what the sign of W. So W is negative since the system is working against the surroundings at the cost of its energy. That means you have supplied some heat energy. Let us assume like this. You have a weightless, frictionless piston. Ideal gas is present here. Now you have supplied some energy Q. By absorbing this energy, it pushes the piston upwards against P external. Let us say this is P gas. So here P gas is greater than P external. In such case, the piston moves upwards, then the work is done by the gas. When work is done by the gas, W is always negative. Suppose if you do the compression work, exactly the reverse. You take 1 mole of again an ideal gas. Now you have pushed the piston downwards by applying pressure or keeping some weights on the piston, whatever the way you do. These are weights. Thus the piston moves down. Then work done on the system, W is equal to positive. Work done on the system, W is equal to positive. Work done by the system, W is negative. These two are very, very important things. So we have already discussed about the work done in the reversible expansion of an ideal gas. You see your notes, you will find this minus 2.303 nRT log V2 by V1. Work done by the gas with a negative sign. Or in terms of pressure also, same formula just with a little change, as pressure and volume are inversely related. It is P1 by P2. These are the two derivations we have seen in the last class. Now we are moving to the next point in the PowerPoint presentation. So that is the work done in the free expansion. See this one. Free expansion or expansion in vacuum. So what we are going to study? Free expansion or expansion in vacuum. Free expansion of an ideal gas. This is also called expansion of an ideal gas in vacuum. So then the diagram will be like this. A cylinder enclosed with a weightless, frictionless piston. Outside is vacuum. So if the gas expands, because there is nothing outside, there is no pressure, so P external is equal to 0, because outside is vacuum. Then in the relation W reversible or irreversible, whatever it is, so W irreversible is equal to, our heading is free expansion or expansion vacuum. W irreversible is equal to minus P external into delta V. This P external is 0. That's why W irreversible is equal to 0 into delta V. So W is equal to 0. This is a very, very important point. If it is reversible also, for reversible, the equation corresponds to W reversible is equal to minus integral P external dV. It is integrated between V1 and V2. This is again 0. That's why W reversible is also 0. So what is our statement? What is our statement? In the free expansion of an ideal gas, the work done is 0. The work done is 0. Whether it is a reversible process or irreversible process. Whether it is a reversible process or irreversible process, work done is 0. Because they are asking statement type questions. In that they ask the statements like this. The mathematical form of first law of thermodynamics, I am giving the first statement. The mathematical form of first law of thermodynamics, delta U is equal to Q plus W. That is my first statement. The second statement, in the free expansion of an ideal gas, the work done is 0, whether it is reversible or irreversible. Third statement, when work done is equal to 0, as per the first law of thermodynamics, delta U is equal to Q plus W, and we know W is equal to 0 in free expansion. Then delta U is equal to Q plus 0. So there is no work, whatever the heat given in the free expansion, we will change its internal energy, because W is equal to 0 in the first law of the, according to the first law of thermodynamics. So this is the next one. How many statements are over? First statement. What is the first statement I have given? Which one? First law of thermodynamics, delta U is equal to Q plus W. What is the second statement? The work done is 0 in case of free expansion of an ideal gas, or in case of expansion of an ideal gas in vacuum. Because in vacuum P external is 0. No work is done. The third statement is, if W is equal to 0, then the first law of thermodynamics condenses to the form of delta U is equal to Q. Now the fourth statement I give, all spontaneous processes are irreversible. So how many statements are correct? All four statements are correct. Write one more point. The phase transformations. The phase transformations are examples of isothermal process. Are examples of isothermal process. What is phase transition? For example, I take H2O solid, that is nothing but ice, reversible to H2O liquid, that is simply water. So the solid state ice is converted into liquid state water. Now the forward reaction, delta H is equal to, is it exothermic or endothermic? Ice converting into water in the forward reaction or forward change, the delta H, is it positive or negative? So general common sense, even 5th class student will tell, to melt ice you have to give heat energy to the ice. It is melting of ice. So delta H is positive. It is endothermic. Whereas the reverse direction, obviously delta H will be negative. That is exothermic. Now this entire process occurs at a constant temperature of 0 degrees centigrade or 273 Kelvin and 1 atmosphere pressure. In one direction, you can see it is called a melting point of ice. In the reverse direction, you can tell it is freezing point of water. It is called phase transition. So the phase, which phase is transferred into other phase? The solid ice phase is converted into liquid water phase. This is called phase transition, which occurs at constant temperature and constant pressure. What is the constant temperature? At 0 degrees centigrade, the ice and water are in equilibrium. We call it as phase transition. Since the temperature of the system remains constant, we call it as an isothermal process. So all phase transitions are isothermal processes. Here I will tell an interesting point. I don't know about your state, but if you go to further east, north and east, you go to Himachal Pradesh or Jammu and Kashmir or the Ladakh region, so Lahul and Spiti regions. So these regions, in the winter, they have very high amount of snowfall. In India, only a small part is experiencing snowfall. But if you go to Canada, US, eastern part of US, every day is a snowfall. Snow is deposited on the roads, the ice breakers comes, break the ice and clear the roads. Skidding of cars is also common there. So the car's tires are fitted with a spiked chain. Only with that you can drive the car in the winter. So why I am telling this, there is an application of this phenomenon there. Suppose you are standing in the outside, just as snowfall is announced, you are eager to see the snowfall. So it started, the snow is falling. Immediately after snowfall, you feel very warm. Actually, you should shiver. But the important point is, immediately after snowfall, the people in that atmosphere, that area, feel very warm. After that, they feel very cold. There's a different thing. So why immediately after snowfall, the people feel warm? Because the liquid water in the atmosphere transfers into ice. So liquid water transferred into ice is exothermic. Heat is given to the surroundings. So the water in the atmosphere, liquid water vapor, condenses and transforms into ice. It is an exothermic process. So the heat is given. The heat is transmitted to the surroundings. So surroundings we feel very warm. Similarly, ice occupies more volume. Water occupies less volume. This is also a very interesting point. Usually solids should occupy less volume, but usually in case of water, ice occupies more volume. Because in ice, each water molecule is tetrahedrally bonded with 4 other water molecules by intermolecular hydrogen bonds. So this is a question actually, neat question. What are the maximum number of water molecules that can be present around a single water molecule? The answer is 4. That is also in ice. So ice has a unique structure in which a single water molecule will be tetrahedrally linked with 4 other water molecules by means of intermolecular hydrogen bonds. And that gets repeated and it forms a 3-dimensional cage-like structure. This 3-dimensional cage-like structure makes ice to float on water. Actually, solid should sink to the bottom, but ice is floating on the water because it is less denser. Why is it less denser? The water molecules are not closely packed. They are tetrahedrally arranged in a 3-dimensional pattern and it forms like a cage-like structure. Each water molecule is surrounded by 4 other water molecules. So all these unique properties makes ice less dense, occupy more volume, floats on water. But if you melt ice, the hydrogen bonds are broken. The water molecules come nearer. It occupies less volume and more denser. Liquid water is more denser than solid ice. Why? When solid ice is melted, the hydrogen bonds break, the cage-like structure collapses, and the water condenses. and very close packed molecules will be there. Thus it is more denser and occupy less volume. So this is the principle in the skating on the ice skating. So in ice skating, what the skater do? He wears a skating shoe. Of course, he should be having a well practice about it. Otherwise, he will skid, all the bones will fracture. So in the skating season, the orthopedic doctors in the countries where skating is more predominant, they are full busy. Everyday cases. However, precautions they take, they fell. That is Formula One, 7 times Formula One champion. What is his name? Schumacher. Correct? You don't know? Or you don't know about sports, games, politics, science, technology, nothing. Only youngster, campus. So just some students are singing that, at least that is a better thing. At least they are opening their mouth. No, students should not be like that. At least some of you are playing volleyball or football. That is also a good sign. But you should be having multidisciplinary things. So next time you ask your management to provide newspaper. Okay, the Formula One champion, 7 times Formula One champion, is a German actually. Michael Schumacher, his name. Not that Schumacher means he makes shoes. So this Michael Schumacher, along with his son, because 7 times Formula One racing champion means world champion, means the money is huge. Billions of dollars of money is having. So along with his son, they are skating in France, in the mountain regions of Alps mountains. But they are wearing the protective suit, helmet, shoes, gloves, everything they are wearing. All protective measures they have taken. This Michael Schumacher, while negotiating a curve, while skating, he accidentally slipped and fell down. And just when he is falling down, there is a big ice boulder. And his head hit to the ice boulder. So the helmet was shattered because the impact is so heavy. And there is an injury to the brain inside. Though brain is floating in cerebrospinal fluid, he got injury to the brain. So immediately the French doctors examined, they took MRI and all these things. And at that point of time, to operate and remove the clot formed in the brain is a very risky thing. That's why they contacted even more neurologists, neurosurgeons, many doctors, and finally they concluded it is not at all safe to operate and remove the clot. Let him be under coma. Every day they use it to give an injection, he is in coma. It is called induced coma. Almost 1.5 years is in coma. And doctors also took precautions that his body temperature should not rise. So 2 things they are maintaining in an ICU, giving an injection, keeping him under induced coma, seeing that his body temperatures are not rising. And meanwhile they are introducing blood thinners which can dissolve the clot, like aspirin. Aspirin is an analgesic, acetyl derivative of salicylic acid. This is aspirin. 2 days back we discussed salicylic acid for intramolecular hydrogen bonding. The OH and COH groups are side by side. What, Dr. Saab? Listen and read the notes also. So COOH. In the place of OH, if O is H is replaced by acetyl group. This is acetyl group. So it is acetyl derivative of salicylic acid. This is called aspirin. It is actually introduced to the medical field as an analgesic. Analgesic means pain reliever. So if you have a headache, immediate doctor will give an analgesic like aspirin. Immediately, miraculously, the pain will be relieved within few minutes. That much wonderful drug it is. Later, the research shows it is not only a pain reliever for the human body, it is also blood thinner. You all know as biology students, the fluidity of blood is maintained by a hormone called heparin, secreted by liver. Is due to blood clots in the brain, one or multiple, we don't know. So when aspirin discovered that it is a blood thinner, WHO recommended those who cross 50 years of age take 75 milligrams of aspirin every day as a precautionary dose. Then your blood become thin fluid, no clots will be formed. There is no question of sudden heart attacks, sudden paralytic strokes. So that is, of course, for some patients, doctors also give low molecular weight heparin to dissolve any clots in the heart. That all depends on the cardiologist. Now, this aspirin is slowly injected into the blood of the Michael Schumacher to dissolve the clot and not keeping him awake. He should be always sleeping under coma. So medicine is very expensive in foreign countries. Doctor fees are very high. Hospitalization charges are also very high. That's why what Schumacher's wife did, she constructed a mini hospital in Germany, exactly replicating the France hospital where he is treated upon. And she hired some doctors to regularly visit Germany to give any suggestions and go back to their original work. Now only 3-4 days back, I read a news. We don't know what is his health condition of Schumacher. After 2 years, he came out of coma. And the health secret, generally health issues in abroad are only discussed with the doctor and patient. They are not revealed to the third person. That's why the family kept this entire thing secret. Whether he is walking or restricted to wheelchair, whether he is able to talk or not, we don't know. But recently his daughter got married, in which he appeared, walking and freely mingling with others. So after almost, I think it all happened around 10 years back. After 2 years, he came out of coma. So actually the principle is Le Chatelier principle. Why I told this entire episode? Chemistry is involved here. So actually the chemistry is, when you apply pressure, so if the skater applies pressure with his skating boots on the ice surface. Because his body weight, he applies some pressure and want to move. Then when he applies pressure, whenever pressure is increased, volume should decrease. Volume decreasing direction is right side. Here it is more volume, here it is less volume. That's why the equilibrium shift in the right side direction. So beneath his skating shoes, some water is formed because the equilibrium shifted from ice to water. That water layer formed act as a lubricating medium and allows him to skate. So as he applies once the pressure, more ice melts. This melted ice becomes water, liquid water, and it makes lubrication, smooth moving. That's why the skater keep on moving. Unless otherwise he controls himself, he will fall down. So on walking on ice surface is very difficult. Why? Because you are applying pressure with your feet. Le-Chatelier principle. When pressure is increased, volume decreases. Please come here. You only. Come here. Fast. You are not a old woman, no? 17, 18 years old. So what happened? Are you taking any cough syrup every day? Any cough syrup? Any tablet, anti-allergic tablets? Which one? You are? She is speaking English or Meghalaya? Kasi language?
I take amla juice.
Amla juice. Good for health. Vitamin C. She is taking good precaution. Amla juice. Vitamin C, vitamin C. You do one thing. Every morning time you are taking. Shift to afternoon. Let us see. Because regularly you are sleeping. I have one student called Mr. Reddy. 2 years, every day I am waking him up. I asked him to stand up for some time. While standing, also he is sleeping. Tulsi Ram Reddy is his name. And very interesting, he is having God's gift. While sleeping also he listens to the lesson. And whenever you ask a question, he will give answer. Even we can't punish or even say strong words to him because he is able to answer while sleeping also. Finally, he cracked JE, first attempt. Cracked JE and also he cracked Bachelor of Statistics, B-Stat. You have Asia's first statistical institute, Indian Statistical Institute in Kolkata. It is India's and Asia's first statistical institute. Later they opened a branch in Bengaluru. So you have to write an entrance exam like IIT JEE. You have a B-Stat exam. Once you clear that exam, you will get admission in that. This Tulsi Ram Reddy chose B-Stat because they are highly paid. Students who came out of ISI, Indian Statistical Institute, because there is very less number of students come from that institute. And all major companies require a lot of statistics. Thousands and lakhs of crores of business. To maintain this business, lot of statistics. employees, salaries, income, cost, many things they have, taxes, lot of statistics are involved. That's why he joined that. So after joining in Kolkata, he came and met me. Because every day my duty is every day ask him to wake up and stand for some time. Standing also he is sleeping. I used to call him again, he became again alert and again sleeping. Like that she may also become a doctor. While doing operation also she sleeps. Are you doing any physical activity? Every day you do some physical activity. Take amla juice in the afternoon. Okay? Have deep breath and deep breathe out. More blood will go into your brain. Oxygenated blood makes you very active. That's why all the IAS officers, IPS officers, please sit. IAS, IPS officers, ministers, Prime Minister, they have to be active the entire day maximum. They have a lot of responsibilities. The CM of your state, don't think that he is enjoying the post. Namesake for external people like us, it seems very glamorous. He is having a lot of big convoy, so security, this, that, looks very good. But inside, he has to deal many things in a day. Lot of things, decision making, meeting the press, journalists, are trying to shut the mouth of the opposition parties. Within the party, if any problem is there, he has to subside it. So a lot of things has to be active throughout the day. So what they do every day, they do a lot of breathing exercises. So more oxygen goes into your blood will be more oxygenated, you will be more active. So people who don't inhale properly, they become drowsy like our doctor. And she will be every day sleeping and Sari is coming and waking her. So never sleep now onwards. Okay? Don't give support to your head also. Remove the hands. Give straight, yes. You should enter into Indian Army. So you have to go into AFMC, Armed Forces Medical College, Pune. So AFMC, even if you are a doctor, you are a uniform soldier. So in army caption, whether you are holding an engineer post or doctor post, basically you are a soldier. So doctor also wear the uniform. He should be ready for the war. He should be physically fit. No, I am a doctor, I don't want to wear this uniform. You have to quit and go out. Like that. So, I will give one more phase transition now. That is boiling point of water. So I take H2O liquid, reversible to H2O vapor or gas. So liquid water and water vapor. Liquid water, what about the forward reaction? Is it exothermic or endothermic? Very good. Delta H is positive. It is endothermic. Because liquid water absorbs heat and converts into water vapor. The reverse direction is delta H is negative. This is also a phase change. This phase change occurs at a constant temperature of 100 degrees centigrade, that is equal to 373 Kelvin, and 1 atmosphere pressure. This is called boiling point of water. This is called melting point of ice. Boiling is different from vaporization. Suppose you hanged a wet cloth, you washed your clothes, hanged on a wire. Even just by air only, they become dry up after a few hours. It all depends on the surrounding environment. If it is a humid area, it will take more time to dry up. If it is a dry area, like in Hyderabad, the cloth become easily dried within no time. So are you boiling the water, the cloth, to go the water vapor to out? No. That is vaporization. So the water molecules which are clinging to your cloth, wet cloth, they absorb some energy from the surroundings and they acquire certain kinetic energy and they escape from the cloth. That is called vaporization. So vaporization is different from boiling. In boiling point, the liquid water and water vapor should be in equilibrium. So the equilibrium condition of liquid water and water vapor is only achieved at 100 degrees and 1 atmosphere pressure. That is called boiling point. So boiling point depends on the outside external atmospheric pressure. Under normal 1 atmosphere pressure, boiling point is 100 degrees. No sir, I climbed Mount Everest. I am on the Mount Everest now. Then the pressure is low. On Mount Everest it is only half atmosphere. But after climbing Mount Everest or scaling the Mount Everest, you feel very hungry. You took some rice, potatoes, eggs, dal, a stove, everything is with you. You immediately started cooking. You placed a bowl on the gas stove, poured some water, put some rice. On another stove, you put eggs or dal and you are boiling. After some time you are very hungry, you check the rice whether it is cooked or not. It is just as it is like that. You check dal, it is not cooked. So rice, dal, eggs, potatoes, nothing is cooked on the Mount Everest. Though you are boiling. You see water is boiling, going out. You have to pour more water to boil the rice. As you are pouring more and more water, the water is going out but the substance is not cooked. You break one egg and you see it is all liquid inside. Egg is also not boiled. What is the reason? The outside pressure is less, half atmosphere. When the pressure is 1 atmosphere, water boils at 100 degrees. When the pressure is half atmosphere, water boils at only at 40 degrees centigrade. At 40 degrees, the substances are not cooked inside. So a person who is on the higher altitudes cannot cook the food because the outside pressures. And also you will face one more problem while scaling the Mount Everest. Your blood pressure when you are on the ground level is compatible to the atmospheric pressure. Blood pressure is habituated with atmospheric, 1 atmosphere. But you are climbing Mount Everest. Pressure is decreasing. Outside pressure is less now. Your blood pressure is a dominating factor. Because of the higher blood pressure, a mountain climber bleeds through his nose and ears. Blood is coming out from the nose and ears. That's why if you are willing to climb Mount Everest, the government won't give the permission. You have to take the permission and they ask you, do you have any previous experience? No. Then you climb to this site, stay 2-3 days there. Your body will be habituated to that pressure. Then go to some more distance, stay 2-3 days. Like that you have to accustom your body to low pressures. Directly you can't go. So these are all the problems in mountaineering. Okay, this is all related to the pressures, boiling point, phase changes. And now today we started with the free expansion, or the expansion in vacuum involves no work, W is equal to 0. So from that we are continuing now. Now we have completed this part. So in this, W is equal to minus P external into delta V. If this is 0, W is equal to 0. And you know, this we already completed, this is not required. So you know delta U is equal to Q plus W. In the place of W we can substitute minus P external delta V. So delta U is equal to Q. In the place of W we can substitute this minus P external delta V. At constant volume, delta V is equal to 0, then delta U is equal to Q, or this is also called QV. We already discussed this, but again you are right. So W is equal to minus P external delta V. This is first law of thermodynamics. In the W place we substituted this value and we assumed at constant volume as delta V is equal to 0, delta U is equal to QV. From that you can give a statement: heat of a reaction at constant volume is equal to change in internal energy. Change in internal energy. Next point. In adiabatic process, what is an adiabatic process? Neither heat enters into the system nor leaves the system. Q is equal to 0. So delta U is equal to Q plus W. Since Q is equal to 0, delta U is equal to W. We call it as W adiabatic. Now we also give one more statement here. Work done in adiabatic process. Work done in adiabatic process is nothing but, or is equal to, work done in adiabatic process is equal to change in internal energy. Work done in adiabatic process is equal to change in internal energy. Next, writing the heading, isochoric process. In isochoric process, the volume remains constant. In isochoric process, volume is constant. So delta V, change in volume, is 0. So delta U is equal to Q plus W. We know W is equal to minus P external into delta V. So delta U is equal to Q minus P external into delta V. This delta V is equal to 0. It is equal to 0. So delta U is equal to Q or QV. Again, we have proved that heat of reaction at constant volume is equal to change in internal energy. So in isochoric process, W is equal to 0. As delta V is equal to 0. Now W is 0, already we discussed just now. In free expansion of ideal gas or ideal gas expansion vacuum, there also W is equal to 0. In isochoric process also, what is isochoric process? Constant volume process. What is isobaric process? Constant pressure process. What is isothermic process? Constant temperature process. How many processes with iso? Isothermic, isobaric, isochoric. Isothermic, constant temperature process, like Boyle's law. Isobaric, constant pressure process, like the Charles law. Isochoric process, constant volume process, where delta V is equal to 0. This is first law. In first law, W place we substituted this. And delta V is 0. That's why this entire factor becomes 0. That's why delta U is equal to QV. Next. Work done in vacuum, W is equal to 0, we already discussed. Write this question. Calculate the amount of work done. Calculate the amount of work done in a bulb of 2-liter volume. In a bulb of 2-liter volume and 1 atmosphere pressure, a bulb of 10-liter capacity. Of 10-liter capacity, and in the second case, it is allowed to expand from 1 liter to 5 liter. Allowed to expand from 1 liter to 5 liter against a constant pressure of 1 atmosphere. Now write the answer in case 1. In evacuated bulb, in an evacuated bulb, within brackets vacuum, within brackets vacuum, P external is equal to 0. That's why work done is also 0. So this is the thing actually. A 2-liter bulb, bulb, 1 atmosphere pressure. It is connected to another bulb of 10 liter. Now its volume is 10 liter, but no pressure. Evacuated bulb. Now we remove this partition. Then the gas comes from here to here. While it is coming from here to here, it need not act against any external pressure as it is vacuum. So P external is equal to 0. So work done is equal to minus P external into delta V. So external pressure is 0. So W is equal to 0. In second case, you can use this formula and calculate the work. What is second case? Delta V is equal to V2 minus V1, 5 liters and 1 liter, 4 liters. Pressure is 1 atmosphere. This is case 2. Use the formula again, W is equal to minus P external into delta V. 1 atmosphere into delta V, 4 liters. So 4 liter atmospheres. This is the work done. Four liter atmospheres. But here 1 liter atmosphere is equal to, there is a conversion factor. 1 liter atmosphere is equal to 101.3 joules. We got 4 liter atmospheres is equal to 4 into 101.3 joules, 405.2 joules. This is the work done by the gas. So minus. Why minus? Because the gas is expanding. From how many liters to how many liters? To 1 liter to 5 liters. Whenever gas expands, it do work. Whenever it do work, W is negative. If work is done on the system, suppose if 5 liter is compressed to 1 liter, you will get W positive. Correct? See the 11th question. 1 mole of oxygen is allowed to expand isothermally and reversibly from 5 meter cube to 10 meter cube at 300 Kelvin. Calculate the work done in the expansion. So in isothermal expansion, what is the formula we derived? W is equal to minus 2.303 nRT log V2 by V1 for this problem, mentioned as 11th problem. So what is N value given? 1 mole. R value, since these are in meter cube, R value will be 8.314 joules into T 300 Kelvin log V2 is 10. 5 to 10, okay. V1 is 5. So this is 2 times. So it is minus 2.303 into 8.314 into 300 into log 2 value all know, 0.3010. Log 2 value generally comes, we do know the value. You simplify, you will get the work. One mole of O2 gas is allowed to expand isothermally and reversibly from 5 meter cube to 10 meter cube. write the heading enthalpy. Enthalpy. So all this is not required. The first point you write. The heat of a reaction at constant pressure is a measure of change in enthalpy. So delta H is equal to QP. The heat of a reaction at a constant pressure is a measure of change in enthalpy. Enthalpy is represented with the letter H. Internal energy is represented with the letter U. Now, you write the first relation. Delta U is equal to Q plus W. First law of thermodynamics. In place of W, we can write P delta V. Then the relation becomes delta U is equal to Q minus P delta V. Here also you write, this is QP, because we are doing at constant pressure, QP. Now, delta U is nothing but U2 minus U1, and delta V is nothing but V2 minus V1. Now substituting that in this equation, in the place of delta U, what I can write? U2 minus U1 is equal to QP minus P into, in the place of delta V I can write V2 minus V1. Simply we expanded. In the place of U, what I wrote? U2 minus U1. In the place of delta V, what I wrote? V2 minus V1. Okay, the next point. Now you keep QP here, bring this term to the opposite side. So QP is equal to U2 minus U1 plus, this comes this side, plus P into V2 minus V1. This you can further expand and write like this. This QP is equal to U2 plus PV2 minus U1 plus PV1. U plus PV is nothing but H. H2, this is minus H1. That is equal to QP. That is equal to delta H. Now write a point. In the expression, let us say this is 1. In the expression or in the equation 1, the terms U, P and V, in the expression the terms U, comma, P and V are state functions hence U plus PV also become a state function and U plus PV also becomes a state function and is called enthalpy. U plus PV is also a state function H called enthalpy or called enthalpy within bracket capital H. Enthalpy can also be defined as, next point, enthalpy can also be defined as the total heat content of the system. The total heat content of the system. Or it is also defined as the sum of internal energy within brackets U letter, capital U, and work form of energy. And work form of energy within bracket PV and work form of energy called PV. So enthalpy, the letter H, we are dealing in a number of ways. It is the heat of reaction at constant pressure. That is one way of expressing enthalpy. Or the second way, it is the total heat content of the system. That is the second way of expressing. The third way of expressing enthalpy H is nothing but U plus PV. Here I wrote U2 plus PV2, U1 plus PV1. U2 plus PV2, I write it as H2. And U1 plus PV1 as H1. So U plus PV, sum of internal energy plus what is PV, work form of energy. So what is enthalpy? It is heat of reaction at constant pressure, or it is the total heat content of the system or it is the sum of internal energy plus work form of the energy. So internal energy is U, work form of energy is PV. Next point. Suppose you go a little bit back here. QP is equal to U2 plus PV2. We already wrote this. Minus U1 plus PV1. Q2 plus PV2 we wrote as H2. This is H1. So H2 minus H1 is equal to QP. That is H2 minus H1 is nothing but delta H. So write one more relation. H is equal to, we define this, H is equal to U plus PV. H is equal to U plus PV. After that, you multiply this with delta. So H is equal to U plus PV. I am multiplying with delta. Delta H is equal to delta U plus delta PV. Write the next point. Since it occurs at constant pressure and temperature, the equation takes the form of delta H is equal to delta U plus P delta V, because this delta is not meant for P, it is meant for V, because pressure remains constant. Because heat of reaction at constant, pressure is enthalpy. Pressure must constant. You know PV is equal to nRT, or P delta V is equal to NGRT. Ng is equal to delta NGRT. Delta Ng is equal to number of moles of gaseous products minus number of moles of gaseous reactants. So in this P delta V, I am writing as delta NGRT, because delta V change, number of moles also change. So substituting this here, delta H is equal to delta U plus, in the place of P delta V, I can write this form, delta NGRT, most important relation. Delta H is equal to delta U plus delta NGRT. What is delta NG? Number of moles of gaseous products minus number of moles of gaseous reactants. In case of chemical reactions, delta H is equal to HP minus HR, enthalpy of products minus enthalpy of reactants. In case of chemical reactions, what is delta H? Change in enthalpy is equal to enthalpy of products minus enthalpy of reactants. So all the reactions carried out in the laboratory in open test tubes or open beakers are enthalpy changes. So in open test tube and open beaker, the pressure is atmospheric pressure. So pressure is constant. So whatever the heat of a reaction at constant pressure, it is nothing but a measure of change in enthalpy. So what is enthalpy? It is heat of a reaction at constant pressure. All the laboratory reactions or transformations which are carried out in open test tubes, open beakers, are nothing but enthalpy changes. So after this, we go to the different enthalpy terms. Okay, write one question here. If water vapor is assumed to be a perfect gas, if water vapor is assumed to be a perfect gas, molar enthalpy change for vaporization of molar enthalpy change for the vaporization of 1 mole of water at 1 bar pressure and 100 degrees centigrade is 41 kilojoule mole inverse. Calculate the change in internal energy. Calculate the change in internal energy for the same process under same conditions. For the same process under same conditions. You all know delta H is equal, so delta Ng is equal to 1 minus 0. 1 mole gaseous product is there. Left side there are no gaseous reactants. So delta Ng is 1. But enthalpy change they have given already. Delta H value already they gave. 41 kilojoule mole inverse. They asked delta U, internal energy change. So delta U is equal to delta H minus delta NGRT. Delta H is given as 41 minus Ng is 1 into R value. R value also you have to take in kilojoule per mole because this is given in kilojoules. So 8.314. So 1000 joules is equal to 1 kilojoule. So 8.314 joules is equal to how many kilojoules? So 8.314 into 10 power minus 3 kilojoules. Into T. T is how much? 373. So this will be the answer. 41 minus 1 into 8.314 into 10 power minus 3. Here I think they missed that. Here they used this in kilojoule, this is in joules. Okay, finally they converted. But here only we are converting into kilojoules. So final answer will be 37 point 9 kilojoule mole inverse. Now we can directly switch over to different enthalpy terms. Different enthalpy terms is our next heading. Different enthalpy terms. first one you write enthalpy of a reaction. Enthalpy of a reaction. It is represented as delta RH. The amount of heat liberated or absorbed the amount of heat liberated or absorbed in a chemical reaction at constant pressure and temperature is called enthalpy of reaction. So enthalpy of reaction delta RH is equal to sum of the enthalpies of products minus sum of the enthalpies of reactants. So delta RH, you can also write like that, sigma I AIH products minus sigma I BIH reactants. Sigma is used for summation. What is sigma here? Summation. Adding all. AI and BI are the stoichiometric coefficients of products and reactants. In the balanced equation. So whenever a chemical reaction occurred at constant pressure, then you can write enthalpy of reaction. What is enthalpy of reaction? Delta R. R represents reaction, H represents enthalpy. What is the delta RH R represents reaction. So delta RH is equal to the total sum of the enthalpies of products minus sum of the enthalpies of reactants. That is represented as sigma I summation term. AI H products minus sigma I BI H reactants. So we will observe this with an example. Write that example. The example, CH4, these pens also you should keep ready. Every day you have to pour ink. CH4 gas, combustion of methane, this 2O2 gas gives rise to CO2 gas plus 2H2O liquid. So delta RH is equal to enthalpy of A moles of CO2 plus 2H B moles of water, because A is 1, B is 2, no need of A and B. H2O liquid, this is gas. So these are all the only products. So enthalpy of CO2, enthalpy of water minus enthalpy of reactants. CH4 plus 2H moles of O2 gas. So products enthalpies minus reactant enthalpies. Here HM is called molar enthalpy. Write that point. HM is called molar enthalpy. Next point, standard enthalpy of reaction. Standard enthalpy of reaction. Standard enthalpy of reaction, delta RH naught. This is a symbol. Earlier this is not there. Now extra this scale. Write the point. It is the amount of heat liberated or absorbed when all the participating it is the amount of heat liberated or absorbed when all the participating substances in the reaction when all the participating substances in the reaction are in the standard state, next point, standard state is, the standard state of a substance is, the standard state of a substance is the most stable. The standard state of a substance is the most stable physical state of that substance. The most stable physical state of that substance at 25 degrees centigrade, within brackets 298 Kelvin and 1 atmosphere pressure. Suppose if I ask you water liquid, water vapor, water solid, that is ice. 3 forms of water are given to you: water liquid, water vapor, water in the form of ice. Which is the most stable physical state among these 3 at 25 degrees centigrade, that is room temperature, and 1 atmosphere? Very good, liquid water. So that's why the standard state of water is liquid. Suppose I have given carbon dioxide gas, I also give solid carbon dioxide, which is called a dry ice. What is solid carbon dioxide called? Dry ice, which is used in your rock dances and cinema shootings. When the hero and heroine are dancing in a green lawn, you are the viewer, you are viewing the movie. They are dancing. Actually, they are dancing in a hot, sunny day. But you can see some water vapor, that is fog or mist, is just creeping on the grass. When they are dancing at their legs level, some fog is just going up. You feel that they are dancing in Kashmir. They are not dancing in Kashmir. They are dancing in a very hot summer day. But what is this fog? It is just creeping on the grass. They keep some dry ice here and there. Dry ice is solid carbon dioxide, which is under very low temperature, because actual physical state of carbon dioxide is gas. You have to condense it, liquid, and solidify it. Very tough job. You have to apply huge pressures, very low temperatures. Then only carbon dioxide becomes solidified. But you should not touch solid carbon dioxide, dry ice. You will get severe burn injuries. With the naked hands, you should not touch dry ice, which is very cold in condition. How cold will cause burns? Generally, you know that hot substances will cause burns. No. Dry ice also causes severe burns, because when you hold a block of solid carbon dioxide, it wants to convert into its original physical state, that is gas. It immediately takes intense heat from your body, where your skin is touching that carbon dioxide. It takes suddenly so much of heat from your body and gets converted into gas. So during this process, when suddenly that much heat is taken from your body, you will get a severe burn there. That's the people who are using dry ice in these rock dances. You are a rock dance specialist? He is? No. Light. Little bit. Come and dance. Do a little rock dance. You can't? Who is the rock dancer in our class? You are? Oh, he is. Come. He requires special dress, music, background and all. Oh, that he requires so much of background. Simply won't come and jump here and there. So, what happens if they keep some dry ice in the green lawn here and there? The dry ice part, the cube of dry ice you kept there, or a block of dry ice, it takes intense heat from the surroundings and transform into CO2 gas and escape. CO2 is colorless gas. But once the intense heat is taken from the surroundings, the surrounding water vapor become cool and convert into fog. So the fog is artificially created there. The actual atmosphere is not a very cool atmosphere. We have created an artificial fog. So like that they keep so many pieces here and there. So while the shooting is going on, they keep big blocks. So they are taking heat from the surroundings. Surrounding water vapor converts into condense and form into fog. Fog is droplets of water, liquid water, that appears white in color. That's a white color fog or mist is creeping on the grass lawn. So you are seeing in an AC theater, you are enjoying, but really they worked very hard. Of course, they are heavily paid also. In India, cinema actors' fees is very high, crores of rupees. Do you have local Meghalaya cinemas? In your local language, cinemas are there? Yes or no? They are there. Acha. Who is that actor? Famous hero? In Meghalaya, you are? Because why I am asking, in our language Telugu, the most number of movies are produced in India. Horrible people, every day a movie. And the stupid people are also seeing those movies with so many names, no content, no fun. Some are good, very good. Like that, I don't see movies. No, I never saw any movie so far. Maybe at very young age I might have seen. I don't remember also. But after 10th class, I still now, I have not gone to any theater. One day very interesting thing occurred. I am traveling to Mangalore in Karnataka by flight, Hyderabad to Mangalore. One person sitting in the adjacent row, we are side by side. All people are sitting, looking at him. They are almost peeping at him. I saw he is normal person. I don't know who is he. Because I don't have cinema background. So when we reached the destination, we are alighted the plane. And one woman is saying to him, you are the great director, like that she is praising. So after that we went by a bus, we reached the place. We are about to collect our baggage. He is also standing, all are taking selfies, selfie photos. I am just looking at him. He invited. Arey, you stupid, you also come and take a selfie. So, selfie was taken. I posted to my family members. Then they said they have wondered, he is a great director who directed the movie called Bahubali. I don't know Bahubali, I don't know him also. Like that, I don't have knowledge. But I know that Hindi, Telugu and Tamil, these are the three Indian languages where a lot of movies are made. So there's so many actors, so many movies, so much of money, hundreds of crores as a fees. So, and one of my students is also famous actor now, hero. My daughters are telling, he is your student sitting in the front bench. Can't you recognize? No, I can't recognize him. No. So now he is acting. He is a famous hero in Telugu. It is called Tollywood, like Bollywood. Okay, that is a different story. So, standard state. Standard state is the most stable physical state. At what conditions? 25 degrees centigrade, that is 298 Kelvin, and 1 atmosphere pressure. So if the reactants and products are in the standard states, then the heat evolved or absorbed is called standard heat of reaction. Delta RH above superscript 0, a hyphen. So how to represent standard heat of reaction? Write a question. Which of the following represents standard heat of reaction? Standard heat of reaction. H2 gas plus O2 gas, 2H2O gas. This is one. H2 gas, 2H2. 2H2 gas plus O2 gas, 2H2O solid. H2 gas plus O2 liquid gives rise to 2H2O liquid. 2H2 gas plus O2 gas gives rise to 2H2O liquid. In these four, which reaction represents standard heat of reaction? I asked a very damn easy question. Which option? Speak loudly, right or wrong? Very good. Fourth option is correct. He is right. Because the most stable physical state of hydrogen is gas at 25 degrees. The most stable physical state of oxygen is also gas. At 25 degrees centigrade, water is in the liquid state. So this equation represents all the participants are in their standard states. All the participants are in their standard states. That's why the delta H, delta RH is some whatever the value. We don't by heart those values. They will give the values. Examiner will give the values. So that is called standard heat of reaction. Now going back, after standard enthalpy of reaction over, write the next heading. Standard enthalpy, not standard, enthalpy of phase transformation. Enthalpy of phase transformation. In this, you have three. Okay. So enthalpy of phase transformation. You write this heading. This includes enthalpy of phase transformation includes number 1, enthalpy of fusion. Enthalpy of fusion. Delta fusion H. This is number 1. Enthalpy of fusion. Next, enthalpy of vaporization. Enthalpy of vaporization. That is number 2. Enthalpy of sublimation. Delta sublimation H. So enthalpy of phase transformation contain 3 subheadings. What are those? Enthalpy of fusion, enthalpy of vaporization, enthalpy of sublimation. Take a 10 minutes break. After that we continue. How a solid is fused into a liquid. We call it as enthalpy of fusion. Delta FUS H and a superscript with a circle and a hyphen. So for that, write the subheading enthalpy of fusion. The enthalpy change occurs when 1 mole of a solid substance undergoes melting in its standard state. When 1 mole of solid substance undergoes melting. In its standard state. For example, H2O solid. This is 1 mole of ice. Gives H2O liquid. This is 1 mole of water. So this is actually called fusion or melting. Fusion or melt. Both are same meaning. So one mole of solid is converted into liquid state. The heat change accompanying this reaction or proceeding with this reaction is called enthalpy of fusion. Here delta fusion H is equal to the value they have given, 6 kilojoule per mole. Six kilojoule per mole. So when you want to convert 1 mole of solid ice into 1 mole of liquid water, so that is transforming one state to another state. It is enthalpy of transformation. Who is transforming into who? A solid is transforming into liquid. So solid to liquid transformation is nothing but melting or fusion. You can call it as melting or fusion. So whatever the heat change involved in this reaction is enthalpy of fusion. That is 6 kilojoule per mole with a positive sign. Means enthalpy of fusion is always endothermic. Write that point. Enthalpy of fusion is always endothermic. And enthalpy of fusion occurs always at constant pressure within brackets 1 atmosphere and at a constant temperature. Within brackets 273 Kelvin. So how much energy you are giving? 273 Kelvin temperature and 1 atmosphere pressure. When you provide these, when solid ice melts and give liquid water, this is fusion, solid to liquid. The amount of heat absorbed is 6 kilojoule per mole. This is called enthalpy of fusion. Here very important point, just earlier I discussed. If the process is reversed and an equal amount of heat is given to the surroundings, that's what I discussed in the morning session. That's why whenever a snowstorm comes, snowfall occurs, why the people feel very hot or warm? Because if the reverse process, that is liquid to solid, 6 kilojoule per mole energy is given out to the surroundings. Write that point also. When liquid water transforms into ice, when liquid water transforms into ice, 6 kilojoule per mole heat is given to the surroundings. 6 kilojoule per mole. If liquid water transforms into ice, 6 kilojoule per mole heat is given to the surroundings. That's why immediately after snowfall, that's why immediately after the snowfall, people residing in that area feel warm, feel very warm. Next, second one, enthalpy of vaporization. Your next heading is enthalpy of vaporization. So the symbol is delta H vaporization. Delta vaporization H. Vaporization, capital H. The enthalpy change that occurs when 1 mole of a liquid at constant temperature and constant pressure, when 1 mole of a liquid at constant temperature and pressure changes into vapor state, this is always endothermic. That is, delta vaporization H is always positive. Example, H2O liquid 1 mole to H2O gas. Of course, this is also 1 mole. And delta vaporization H is equal to the value they have given plus 40.79 kilojoule per mole. So a liquid converting into vapor, 1 mole of liquid to 1 mole of vapor. So delta vaporization H is 40.79 kilojoule per mole. But this occurs at a constant temperature of 100 degrees centigrade and 1 bar pressure or 1 atmosphere pressure. This is constant temperature and constant pressure. This is enthalpy of vaporization. It is always endothermic. It is always endothermic. Now, you may ask me, how different liquids have different enthalpies of vaporization? Suppose I ask one student to keep their hands open. In one hand I poured water, in another hand I poured some petrol. In both hands they are keeping two liquids, few ml of water, 5 ml water I placed in this, 5 ml of petrol in this I placed. So within few minutes, the hand in which petrol is present, it will feel cool. The hand is feeling very cool. The petrol is vaporized. Water is still in the liquid state. Because water is a polar molecule. In polar molecules, you have strong dipole-dipole attractions. So by absorbing your body heat, the water immediately won't transform into vapor state. But petrol contains hydrocarbon molecules. Petrol is a mixture of hydrocarbons. Hydrocarbons are non-polar. What are the attractive forces in non-polar molecules? Weak London dispersion forces. So the weak forces require little energy. They absorb your body heat. Whenever body heat is taken, you will feel cool. And it goes into vapor state. So those liquids which have more tendency to undergo vapor state are called volatile liquids. Those liquids which are having less tendency to go into vapor state are said to be less volatile or sometimes non-volatile. So liquids are two types, volatile liquids, non-volatile liquids. What are volatile liquids? Those liquids in which the intermolecular forces are weak, like your perfume spray. When you spray some perfume on your hand or on your forearm or on your face or wherever you spray, very soon it takes body heat and goes into vapor state. Even you won't see any wetness. It's already gone, vaporized. It contains a volatile liquid like ether. Ether solvent they use and add some perfume in that. So like that. So liquids are two types, volatile liquids, non-volatile liquids. So non-volatile liquids are less volatile liquids. You can give water, coconut oil. Will coconut oil easily change into vapor state? No, because coconut oil contains more hydrogen bonds. It is a more oily liquid. So coconut oil won't become that much easily into vapor state. Almost it is non-volatile. Or you pour some honey in your hand and entire day you are watching it. The honey will be there only. Unless otherwise you have to lick it and taste honey. That's all. So this is all about enthalpy of vaporization. Now the next one, enthalpy of sublimation. Enthalpy of sublimation. So what is the symbol for this? Delta sublimation H. Like the earlier two we discussed. Enthalpy of fusion we discussed. Enthalpy of vaporization we discussed.